Hi guys, welcome to today's lesson. So we are going to be looking at introducing functions. Guys, this is the most important lesson that we have because it outlines all the important things that we need to know about functions, and then we'll look at the different types of functions at a later stage. But for now, let's look at our mind map and see exactly what we are going to be going through in this particular series of lessons that we're going to have. So, when you talk about functions, we have four types of functions, which is the linear, the quadratic, the hyperbolic, and the exponential. We're going to look at them at a later stage in terms of what exactly each function is all about. Then, the main definition that we're going to look at for all the types of functions is the domain and the range. We're also going to look at the notation of how do we write down a function in terms of its equation, rather the rule, which is what we're going to be calling it going forward. Now, the keywords for this particular lesson will be the function itself. What is the function? A domain, a range, and a Cartesian plane, because all the functions are plotted on what we call a Cartesian plane. Now, a function is a mathematical relationship between two variables where every input value has only one output value. Now, the most important thing here, guys, is every input that you have must only give you one output value for it to be called a function, right? But there's two types of these cases where one input value gives us one output value. As soon as you have two inputs that are giving you one output value, then you are having a problem that we are talking about there. So that's what you need to please look at when you talk about functions. Now, there's two types of them. The first one is called a one-to-one function, and then the other one is called a many-to-one function. Now, graphically, or rather for you to see the numbers, if it's a one-to-one, it means every one input value has only one output value. Every one input has one output value continuously so. When it's a many-to-one, the first input value is -2. It gives me 4, right? But also 2 also gives me 4. But if you look at it, the -2 and the 2 are two different values. So this is a unique value with a unique answer, and this is a unique value with a unique answer as well. So it's not necessarily that both of them are the same number. No, it's -2 and +2. And similarly with -1 and +1. And I will show you this in terms of the graph. How do we see it as well? Now, a domain of a function will be the set of all the input values for which the function is defined. So in terms of a Cartesian plane, we'll be talking about the x-axis, which I'm going to show you later on. And then the variable representing the input values, we normally refer to it as the independent variable. Remember, independent, it means it is the one that is continuously changing. And then the range of a function will be the set of all the output values that result from the input values. So what this means is, for me to get a range, I must have a domain in order to get to that particular range, because a range is an output. And the variable then represented there is called the dependent variable of that particular function. Now, with a Cartesian plane, guys, a Cartesian plane is defined by two perpendicular number lines. The most important thing here is they must be perpendicular to each other. Perpendicular means they form a 90-degree angle, right? So as soon as you have two lines now that are, one is a slant line and the other one is a slant line, and you want to claim that that is a Cartesian plane, that's not going to be possible. So most of the time, whenever want you to draw things on a Cartesian plane, we'll give you a grid, right, where you're going to draw your Cartesian plane. Why? Because we want it to be one vertical straight line, one horizontal straight line, and where they meet, they must make a 90-degree. Not that you must indicate it, but they must make a 90-degree. Now, the horizontal axis, we call it the x-axis. And then the vertical axis, we call it the y-axis, which is also called the vertical axis. With this Cartesian plane, the x-axis and the y-axis are used to describe any point in the plane using an ordered pair of numbers. Remember, ordered pair of numbers, we normally call this coordinates. So the location of the point is given by those coordinates. So on a Cartesian plane, if I say to you, what is A? It means you need to look at what is the x value of A and what is the y value of A. And where they are meeting there, that's where the A will be. So you will give me the actual location of the point based on the x value and the y value, as I'm showing you here. And we normally use a semicolon in between the two variables to indicate an AND situation, that this is x and y, not x comma y, because that means something completely different. And then the first number x gives the point's horizontal position, right? As I said, with the point A that I spoke about, if I say A has the x and the y there, the x represents where A is in terms of the horizontal axis, so it will be somewhere there. And then the second number, which is y, gives the point's vertical position. So where is it in terms of the vertical axis there? And that's how you get it. And then all positions are measured relative to what you call a central point, which is actually called the origin. Now, because I said these two things are number lines, it means the origin will be 0 and 0. So you can't have a number line having the central point of it as anything else other than 0. So it always starts from 0 to the positive, 0 to the negative. Now, I will try and show you how to represent a point on a Cartesian plane. Firstly, we need to understand what does the 5 mean and what does the 2 mean. The 5 means that it's 5 units to the right. So this is the horizontal axis of the origin. And then the 2 in terms of the y will mean it's 2 units up. So on a Cartesian plane, this would mean 5 is 5 units to the right, so I will move until I get to 5 there, right? So this is where my 5 is. And then the 2 means I must go 2 units up, which will land me at that particular point. So my point A will be the 5 and the 2. So even after you plot it, you always just open the 2 round brackets and write down what the values of the x coordinate is and the y coordinate is. Please just try to do that. And the brackets that we use are only round brackets, guys, when we get to a Cartesian plane and functions. We do not use the square brackets. We use them when we talk about the domain and the range, which we're going to mention at a later stage. Now, we have what we call a vertical line test. The vertical line test will be a visual way that we use to determine whether a graph represents a function. The misconception is every graph is a function. That is not true. Remember, I said there's only 2 times when a graph is a function, is when one input value gives us one output value, or many input values gives us one output value. So for me to show you when it is a function, a vertical line intersects the graph in all places at exactly 1 point. If it is only at 1 point where my vertical line test, which is this line here, intersects this particular graph, so you can see it intersected there. If I was to move it to there, it will be only at that point. If I move it there, it will be only at that point. If I move it there, it will be only at that point. So every time you can shift it to the right, you can shift it to the left, it will only intersect the graph at 1 point. Then my conclusion will be the relation is called a function. But on the other hand, is not the case, where a vertical line intersects the graph in some places at more than 1 point. then the conclusion will say this is not a function. What do I mean? If I draw a circle, you can see that if I draw a vertical line every time, it will always intersect the graph at 2 points. If I move it maybe left, you can see also it is 2 points there. If I move it more left, it is 2 points there. So at no point does it touch the graph or intersect the graph at only 1 point. It is always going to be at 2 places. You move it at 2 places. So my conclusion will therefore be it is not a function. Now, when it is not a function, what do we call it? We just call it a relation, right? A relation meaning there's a certain relationship between the x values and the y values, but that's where it ends. That relationship is not classified as a function. So how do we test it? Using what we call a vertical line test, which you please need to also know, because at times we are going to ask you, why is this a function, right? Or why is this not a function? Or test whether this is a function. How to do that? You must use a vertical line and move with the vertical line. So everywhere you draw the vertical line, for it to be a function, it must only intersect whatever graph you have at 1 point. It doesn't matter whether you're moving it left or right. And then if it intersects it at 2 points, then it is no longer a function. Guys, I hope you're having so much fun. I know this might be a lot, but if you please follow everything that you're going to do here, I promise functions will be clear for you. But for now, let's take a quick ad break, and when we come back, we'll look at some more definitions that we need to know under the concept of functions. Please stay tuned. Hi guys, welcome back. I hope you've had a quick rest of some sort, that we are going to actually continue with our definitions. But for now, we're going to look at how do we then write down these functions in terms of rules. Algebraically, how do I write it? We call this the notation, right? So how do you take what I've shown you in terms of a graph and how it looks, and how do you then write it down with symbols on a piece of paper so that it means the same thing? That's what we're going to look at now. So let's look at firstly, what is a notation that is to do with functions. Now, when you talk about a notation, every function is represented by using either f of x, g of x, or h of x, and my ellipsis there means that you can continue. You can even take a of x, you can take z of x, it does not really matter. But what that means that the f of x, the g of x, the h of x, the a of x, and the z of x, they all represent the output value when the input value is x. So the f, the g, the h will be the label of your function, right? So you need to understand this. F of x means that f is the label of the function that you are talking about. Not that it means a specific type of a function. No, it can be any function that you have. It will be labeled as f of x. So the f represents the label, and then the x inside the bracket represents the input value. And then the whole f of x represents the output value. So please understand this. I will repeat. F, G, H, A, Z do not really mean that it's a specific function. No, it can be any function. Because remember, we're going to talk about types of functions, right? So it doesn't mean that f is only linear or quadratic or hyperbolic. No, it can be any function, as long as it has an x value and a y value. And the y value is normally the f of x, right? So the output value is the same as the y value. Now, what I mean is, the f of x here, I can also write it as y. I can also write it as y. So I can write this as f of x is equals to something, right? Where there's an x and some numbers Or I can write it as y is equals to the very same thing. It will really mean one and the same thing because f of x is the same as y, which is the output value. Now, to evaluate a function at a specific input value, the first thing you need to do will be to plug in the input value for the input variable wherever it appears. So this simply means that you need to substitute, right? You need to substitute wherever you are seeing the x value. And then you perform the operations that are specified by the function to calculate whatever the output is. So for example, if I gave you the function as 2x plus 1 not equal to, so if I say 2x plus 1, right? So it's f of x equals to that. It means that if I want to find a specific point, maybe at x is equals to 3, it means wherever I see x, I must substitute it by the 3. So replace it by the 3, which will make it 2, open the bracket, 3, and then plus 1. Now, some people will ask, do I only use brackets or do I use multiplication? My advice would be always use brackets, even if the number is positive or negative. Why? Because as soon as it becomes negative and there are no brackets, some of us forget that I must multiply between these two things. So you'll end up saying 2, if my 3 was negative, you'll say 2 minus 3 plus 1. You see, now you have changed the whole thing. It's no longer 2 multiplied by minus 3. So always use brackets, because brackets and multiplication is one and the same thing. So I would really, really suggest always, whether positive or negative, just use your brackets. And then perform the calculation. So 2 multiplied by 3 will be 6, plus 1 will be 7. So it means when x is 3, y will be equals to 7 for the imaginary function that I gave you here in terms of the example, right? Now, when you then write down the input-output pairs, you're going to write them as a coordinate pair, where the input value is the first one in the bracket. Remember the semicolon, and then the output value, and then you close your bracket. So, in terms of algebra, this looks like this. It will be the x, open the bracket first, rather, x, the semicolon, y, and then close the bracket. And that's how you can then write the input-output pairs as a coordinate pair. Now, just to show you a few calculations that have to do with this, if x is equal to 0, it means that I will need to plug in 0 wherever I see x there, and then perform the calculation. So that will be f is to 0, right? Because remember, I did mention that the x value here will be the input value that we need to substitute in. So that's why I write it as well as f of 0, not just f of x, because I'm removing the x and substituting it by what I know x as. Then 2 multiplied by 0, we know is 0 plus 1, it will give me 1. So it means here, if x is 0, my y is equals to 1. Then the second one, if x is equals to 1, it means it's f of 1, then it becomes 2 multiplied by 1 plus 1, which will then be 3. So if x is 1, then my y is equal to 3. And then the last example will be if x is 2, it means it's f of 2. So wherever there is x, you must plug in the 2, which will then end up giving us 5. So the y value here will be equals to 5. Now, I'm just going to show you the pairs themselves. So remember, my pairs are 0 and 1, 1 and 3, and 2 and 5. To explain what this means, it means that the x value, if it's 0, it is at the origin. The y value, you move 1 unit up from the origin. So that's how you are going to plot these things in terms of a Cartesian plane, right? then when when x is 1, it means that it is 1 unit to the right of the origin. So from the origin, you move 1 unit to the right. And then the 3 means wherever you land after you move 1 unit to the right, you move 3 units upwards, right? Also, it will be 3 units from the origin. And then the last one is 2 and 5. So 2 means that it's 2 units to the right of the origin. And then remember, 5 units up from the origin. Now I'm going to show you how to do this. The trick here, guys, is to join these things with a straight line at the end, provided it is a linear function, right? Or join it with a curve, whatever it is that can join those points when you're dealing with functions. But when you're plotting those points, if you are not familiar with how to do it and you are still trying to grasp this thing, I would suggest that you use a dotted line. So on your piece of paper, when you are working it out, there's a Cartesian plane, right? And then you take a pencil, you move with a dotted line from 0, 1, right? You land at 1. And then 1 goes with 3. From 1 there, you move with a dotted line again, 3 units up. And then at 3, you make a big dot. That's where your point is going to be. So please just try to learn this. I said, from the origin, you move with your pencil with a dotted line in whatever direction, but right now it will be to the right. And then from there, you move again with a dotted line upwards or downwards, depending on what the y value is. Practically, let's see what exactly do I mean. Now, remember, I'm just going to quickly copy them down. It's 0 and 1. So it's 0 and 1. It's 1 and 3, and then it's 2 and 5, right? So the 0 and 1 will be from the origin there, you move 1 unit up, so it will land me at that point. That's point number 1, I will call it A. And then at 1 there, when you move 1 to the right, you must move 3 units up, so it will land you at that point there. And then at 2, you must go 5 units up, so it will land you at that point there. And then at the end, you will need to then join this with a ruler. You can see if you try to do it freehand, it will not really be so straight, right? So if you join it, it will be something like that. Now, if you use a proper ruler, it will then look like this. So you will always need to, please remember I said you label them with the coordinate pair itself. So you can call this A, you can call that B, you can call that C. You don't necessarily need to do that because they did not specify that it's A, B, and C. But for you to understand them, you can do that. And then you label this as f of x, the line itself. You label it as f of x because that was the equation that we gave you. So that's how you will then plot these points on a Cartesian plane. Remember, the goal is to understand what does the 0 mean, what does the 1 mean, what does the 2 mean, right, from the origin. What does the 1 mean, what does the 3 mean, and what does the 5 mean from the origin. And then use a dotted line if you're still a bit shaky in terms of plotting them on a Cartesian plane. At the end, use a ruler, join them if it is a straight line. If it's something else, a curve, join it with that particular curve. And that is how we will plot those points on a Cartesian plane. All right, guys, I hope you've been enjoying what we've been looking at. But for now, I want us to take a quick ad break, drink some water, stretch a bit so that when we come back, we can do some more work. Please stay tuned. Hi guys, welcome back. So now we are going to look at, as we've been looking at rather the definitions and all of that, now we're going to make it a function specific right? Focus, where we look at the very first type of a function, which we call a linear function. And then we're going to look at all the features that have to do with a linear function and see how do we then see what is and what is not, and try to see how do we actually calculate them as well. Because remember, as much as I want you to see these things, I also want you to know how to calculate them, because maths is all about us doing the algebraic stuff, not just seeing with our eyes. So let's look at the keywords that we need to know when you're talking about a linear function. The very first keyword will be what we call a gradient. Now I've put a slash slope. Why I'm using the word slope is because the gradient is actually a slope of a line, right? But we're not going to be using the word slope whenever we continue with our curriculum of maths. But to explain what a gradient is, I'm going to use the word slope for you. Then we have what you call the x-intercept, and then we have what we call the y-intercept. Now, with a linear function, this is lines in the xy plane. What do I mean by xy plane? I'm simply just saying it's a Cartesian plane that has x and y, as we've been seeing. A visual representation of linear equations. So if I give you an xy plane, let me kind of draw a bigger one rather so that you can see what I mean. If I give you an xy plane like this, and then I draw a line that is a bit slant like that. This line is a representation of what you call a linear equation, right? Not just any line, no, it's a linear equation. And then the linear equation is given by y is equals to mx plus c. I'm going to tell you what the m is and what the c is as well, so please just pay attention to that. Now consider firstly the equation f of x is equals to x plus 1. The very first thing I want you to do is to draw this graph. Now from the previous grades where we're actually doing our maths, we knew that we would use what we call a table, right? A table of values to draw graphs. So you will choose maybe from -3 to +3 or from -5 to +5. But for now, just so that it can be a bit short, I'm using -2 up until +2. Now, whenever x is -2, it means this will be -2 plus 1, which will give me -1, right? So you do know that. And then whenever x is -1, it will be -1 plus 1, which is equals to 0. When x is 0, it will be 0 plus 1, which is equals to 1. When x is 1, it will be 1 plus 1, which is equals to 2. And then lastly, it will be 2 plus 1, which is equals to 3. So my y values are -1, 0, 1, 2, and 3. So I'm just going to write those values here. Remember we said -2 goes with -1, and -1 goes with positive, with 0 I mean, and then 0 we found it goes with 1, 1 goes with 2, and then 2 goes with 3, right? Now, as I've shown you how to draw this, please remember, -2 means 2 units to the left of the origin. So I move up until I land at -2 there, but that's not my point. I must move 1 unit down because -1 is 1 unit down. So this will land me at this particular point here. So that will actually be my point. So let me erase this so that it does not confuse you. And then the -1 goes with 0, so it means it is exactly on the x-axis. The 0 goes with 1, so from 0 you move 1 unit up, so it will be there. And then the 1 goes with a 2, it will be at that point. The 2 goes with a 3, it will be at that point. And then remember, the magical thing happens. You then join these points with a straight line. But remember to use a ruler. So I'm just doing it freehand, but I'm going to show you how it looks if you were to use a ruler. If you use a ruler, then this graph will look like this. So remember, 1 goes with 2 there, 2 goes with 3, it will be somewhere up there, although I'm not really showing it here. And then minus 1, you know, goes with 0, 0 goes with 1 there. Now we need to understand what this graph is made up of, right? This is made up of what we call a gradient, a y-intercept, and an x-intercept. But firstly, the gradient will be the direction and the steepness of the line. So if a gradient is positive, what direction does it go in? If it's big, if it's a big number like 10, how steep is it? That's what we are talking about. And then this is also a line that trends upward from left to right, means that it has a positive gradient, which is what I just explained now, right? So what I mean is, for it to have a positive gradient, it must go like that, right? From left to right, and it goes upwards. And then if it has a negative gradient, it will be from left to right again, but downwards now. So it will move in that particular direction. So these are two different things. They are still straight lines, but in different directions. And then how steep is it is determined by the value, the actual value of the gradient. And then the gradient is normally the ratio of the line's change in y value to its x value. What do I mean? Gradient is equals to m, which is change in y over change in x. And change in y over change in x means that the bigger, or rather y2 minus y1 over x2 minus x1. In terms of the equation that I showed you that gives me a linear graph, y is equals to mx plus c, the gradient will be the m, right? So when you're calculating it, you don't necessarily need to write the full word and say gradient is equals to. No, you can just say m is equals to, and then always write down the formula, please. y2 minus y1 over x2 minus x1. Some people ask, what happens when I switch my values around? If you switch both of them around, it will still give you the correct answer. So y1 minus y2 over x1 minus x2. Not y1 and y2 at the top and then x2 and x1 at the bottom. No, if you switch them around, you must start with the 1s and with the 2s, or start with the 2s and end with the 1s. So please try to make that happen with that. And then we have what we call the y-intercept. So this is where the line crosses the y-axis. That's what we call the y-intercept. It is always where the value of x is 0, right? And then on the equation, the y-intercept is represented by that c there. And then we have the x-intercept. This is where it crosses the x-axis, and this is when the y value is also 0, right? So when you're writing this down, by the way, so if I want the y-intercept, right, I normally write a comma or a semicolon, and then you say let x equal to 0. That's how you write it. And then wherever you see x, you substitute it by 0. If you want the x-intercept, the int means intercept, by the way. You then say let y equal to 0. So wherever there is y, you plug in a 0 there and then start calculating. Now we're going to study this graph quickly and then answer questions that have to do with the intercept and see how do we see them on the Cartesian plane. Now, as you can see, this is crossing the x-axis at that point. It is crossing the y-axis at that point. Remember, what did we say? Where it is crossing the x-axis, we call it the x-intercept. Where it is crossing the y-axis, we call it the y-intercept, right? Now, the y-intercept of the line is located at y-intercept 0 is the x value at all times. This is a standard thing, right? Because when it crosses the y-axis, the x value on the y-axis is 0. So this will be at -2, and then with the x-intercept will be at -1, right? And then quickly my gradient, so I'm going to use the 2 coordinates, which is -1 and 0. I will call these my 1s, and then my 2s will be 0 and -2. 0 and -2. So y2 is going to be -2 minus 0, which is y1, over x2 is 0 minus -1. So -2 minus 0 is just -2 over 0 minus -1 will be +1. So this will just be -2. So my m will be equal to -2. And then if we want to write the formula, remember the formula is given by y is equals to mx plus c. The m value is the gradient, which is -2. There you have it, -2x. The c value is the y-intercept, which is 2 according to the graph that we have. So my equation will then be f of x is equals to -2x minus 2. So with a linear graph, what is important? The gradient and the y-intercept. Do we know how to calculate those? Yes. Gradient is change in y over change in x. Y-intercept, you let x be 0, and then you start calculating. On a graph, it's easier, excuse me, it's easier for you to see them, but in terms of calculating, whenever I've given you an equation, you just plug in the 0 there and start calculating. Guys, I want us to take a quick ad break, get some water. When we come back, we're gonna do more of these linear functions. Stay tuned, please. Hi guys, welcome back. So we are still looking at a linear function and what it is all about, right? So now we're going to try and explore the actual linear function further and see what it is all about and see how do we draw this. I've shown you how to actually plot the points, join them with a straight line. Now we're going to look at some more concepts that have to do with a linear function. But for now, let's have a look at it quickly. Now, remember the linear function, the general equation is given by y is equals to mx plus c, or y is equals to ax plus q. It really means one and the same thing. Just that some textbooks use m and c, some use a and q, but they really mean one and the same thing. Now the value of m or a determines the steepness of the line. Sorry, as I said, then the larger the value of m, the steeper the line, right? And then remember the negative sign will cause a reflection in the x-axis, right? Where the direction then changes. Now the effect of changing the m or the a, firstly, we need to look at which one is the main graph here. And the main graph, we call it the mother graph, where it is the y equal to x, right? Now I want to change this around. Changing it means that I must change the m or the a value, which is normally in front of the x there. If I make it a half, it means this becomes less steep, right? Because we did say the bigger the value, the steeper the line is. But now this is a small value from 1, right? Because if there is no value in front of the x, it means that is 1, right? So if there's nothing there, it's 1. Half of 1 is half itself. So that's why it is a bit shallow. But now, when we have y is equals to 2x, that is a bit more, so it becomes more steeper than the mother graph. And then y is equals to 3x, it becomes way more steeper than this. So you can see, this was 1, it became 2 there, it became 3 there, right? The m value, or the a value. Remember we said they mean one and the same thing. So the bigger the value, the more steep it becomes, right? But the smaller the value, the gentile it is. We normally use the word gentile, either steep or gentile. Then the value of C or Q determines the shift of the graph up or down, right? So we do need to also know what the up and the down is all about, right? So it means if I have y is equals to x as the mother graph, when I say y is equals to x plus 1, the plus 1, because it's positive, it means I must move it 1 unit up, right? But in the very same posture that it is in the same nature it is in, you don't tilt it or anything, no. As is, you just slide it 1 unit up, right? If I say x plus 2, you slide it 2 units up. X minus 2, you slide it 2 units down, right? But I will show you this. But you won't be required to slide them in terms of the paper. No, you are going to write them down and analyze certain things. But you are just sliding it either up or down. That's what the value of C or Q really has to do with. Now, it also represents the y-intercept. We do know that, right? So if I had y is equals to x, it means my C is 0, right? Because remember, anything plus 0 will always be that anything, right? So it means the graph is at the origin. It is crossing through the origin point. But as soon as I make it x plus 1, it means now it is crossing at point 1. Right, on the y-axis. That's what it simply means. So that's why I'm saying you shift it 1 unit up, 1 unit down, 2 units up, 2 units down, depending on what the graph is. So remember again, my mother graph here will be y is equals to x. And then you can always move it up or down depending on what the value is. If I say x minus 2, now that simply means it is 2 units downwards, right? 2 units downwards up until it gets to that point. But as you can see, these two lines are still at the same distance between one another there, right? There's still the same distance between the two lines. Why is this important? Because as soon as maybe the distance here becomes smaller, it means that you would have tilted the line, and that's what will make it incorrect. So we say that these two lines are parallel to each other. It must just move at the same distance. Guys, a typical example of parallel lines will be a road, right? If you look at the road, the distance from this pavement to that pavement is the same throughout the road, unless it gets to a point where it's going to be maybe an intersection, or it's going to be now 1 lane instead of 2 lanes. But if it is still on a 2-lane point, it will always be equal. If you draw a line there and measure it, it must be the same throughout. That's what we call parallel lines. So even with this, when you are moving it up or down, it must always still remain parallel to the mother graph, which is the y equal to x. Now, the second one will be when I move it upwards, which is y equals to x plus 3. So you can see, with this one, we said it crosses at minus 2 because the y-intercept is minus 2 there. But this is positive 3, so it must cross at 3. So the midpoint between 2 and 4, you can see there is 3, although this is in a scale of 2, right? So this is 1, 2, and then 3, 4, like that. So you can see it is actually crossing at that particular 3 there, which is important for you to know. Now, just to summarize what we've looked at, guys, and then I'm going to give you one more example that I want us to please quickly look at. A relation can only be a function if every input value has only, guys, the golden word here is the only one output value. If it has more output values, then you are no longer talking about a function. Now you are just talking about a relation, right? For that relation to be classified as a function, one input must always give me only one output. But it can happen that many input values give us one output value. That is the many to one. But that just simply means that it's unique input values that always yield one output value. But it's unique value. So it's always 1, 1, 1, 1, 1, 1. Although this one on the other side, the output value is the same throughout. So it's 1 to 1 and many to 1. As soon as it becomes 1 to many, it's no longer a function, it's just a relation. And then the linear function has a constant gradient and a constant y-intercept, right? So if now I had said to you, I want you to find the equation, right, which I'm going to write here. Find the equation of A, which has the coordinates maybe 2 and 5, and B, which has the coordinate, we can make this 6 and 9, maybe. Let's just make it like that, right? Remember what I showed you first in this lesson. We looked at if it's a graph and I'm trying to analyze the graph. Now, if I didn't give you the graph and I gave you points, how do you then find that equation? I need you to please think about that and think about it carefully, right? Remember I said the two most important things are what? The gradient and the y-intercept in terms of a linear graph. The y-intercept, it's easy to see it on a graph, right? When I gave you the Cartesian plane and draw the graph. The gradient, whether it's a graph or it's points, it doesn't matter because you always need to calculate it. So here, the very first thing that I know you are thinking about already will be to calculate the gradient. Calculate the gradient, right? And that will be y2 minus y1 over x2 minus x1. And then you plug the values in, which is something that you are going to do. The y2, you can treat it as the b there. The ones, you can treat them as the a there. And then number 2 will be to substitute this. You sub this in the equation y is equals to mx plus c. And then I want you to figure out number 3. How do you then find the third point? What will be the third step that you need to follow there? And I'm going to leave that with you so that you can please just visualize this. Research, guys. I know that I've given you all the basics. Now it's some time for you to actually try work this out. And then we'll see it next time. But for now, I hope you've enjoyed what we've been looking at, guys. Remember, mathematics is food for the soul. If you do it well, I promise it will nourish every fiber in you. But the goal with all of this is just to understand the basics. If you do not know that, then you will not know the bigger things. So you need to know the smaller ones in order to make sense of the bigger things. Guys, from me to you, the Maths Doctor, I will see you guys next time. Mathematics is food for the soul. Until next time.